Hello everyone, welcome back to my channel. So in this video we will learn about binary coded decimal, that is BCD code. Okay, BCD code, right? If you are first time to my channel, please consider subscribing and hit the bell icon to get video notifications from my channel. So we have already discussed three types of binary codes in my previous video, right? So this is the fourth type of binary codes. Okay, so binary coded decimal 8421. Okay, so 8421 is called natural BCD code, right? So for the digits 0 to 9, so binary and BCD code representation is same. Okay, so binary representation and BCD code representation is same for the decimal numbers 0 to 9. That is 9, if you want to represent 9, so in binary it is 1001, in BCD also it is 1001 only, right? So in both cases both representations are same. So but the difference between BCD and binary exists for multiple digits. Okay, so the difference exists for multiple digits representation. Suppose if you want to represent 62. Okay, so if you want to represent 62 in binary, how will you represent? So 2 3 1, remainder is 0, 2 15s, remainder is 1, 2 7s, remainder is 1, 2 3s, remainder is 1, 2 1s, remainder is 1. So we'll take this in reverse order. So 1 1 1 1 1 0 base 2. Okay, so this is if you want to represent 62 in binary, so 62 in binary, so how we are going to represent 1 1 1 1 1 0 base 2. This is representation in binary. And if you want to represent in BCD, so how to represent 62 in BCD is we have to represent separately for 6 and 2. Okay, 62 if you want to represent in BCD, so we have to represent separately for 6. 6 is represented using 4 bits as 0 1 1 0, and 2 is represented as 0 0 1 0. Okay, so this is the representation of 62 in BCD code. Okay, understood? So if you want, similarly if you want to represent 538, so 538 in decimal, if you want to represent in BCD, so how we are going to represent in BCD? So 5 is represented separately, 5 is 0 1 0 1, right? 3 is 0 1 1, sorry, 0 0 1 1 3, and 8 is 1 0 0 0. So this is the representation in the case of BCD. Okay, so you can represent any number of digits like this. Suppose if you want to represent a 4-digit number 5423 base 10 in BCD, if you want to represent, so it will be 0101 0100 0010 0011. So this is the representation in BCD, and so on. Okay, right? So this is how we can represent numbers in BCD. Hope you understood. So up to 9 in 4 digits we have to represent. So binary in 4 digits and BCD also in 4 digits from 0 to 9. So both will be equal. Okay, for single digits both will be almost equal. Okay, so not equal, but you can represent, if you represent in 4 bits, it is equal. Suppose if you have 5, so 5 can be represented in binary as 101, and 5 in BCD is represented using again 4 bits only. You can't represent using 3 bits. Okay, so this is 5 in binary, and this is 5 in BCD. Okay, only 8 and 9 you require 4 bits. So in 8 and 9 representations will be same, right? Similarly, if you want to represent 6, so 6 can be represented as 110 in case of binary, right? So it can be represented in the 0110 in the case of BCD. Okay, so if you want, you can keep a 0 here, so representation will be almost same. So that is the point which I have told you here, not exactly same, but almost same. Okay, so even if you keep zeros towards left side, that is towards MSB side, it doesn't make any difference. So almost representation is same, but for multiple digits entirely different. See here, 62 is represented here like this, and 62 is represented like this. So how many bits are required here? 6 bits are required to represent 62 in binary. And how many bits are required here in BCD? It is 8 bits. So to represent a binary, to represent a decimal number 62, we required 6 bits in binary and 8 bits in BCD code. Okay, similarly, if you find 538 in binary, you'll come to know that it requires less bits to represent the same binary number, same decimal number in binary when compared to BCD. So binary requires, so disadvantage here, very important point. So disadvantage in the case of BCD code is it requires, when compared to binary number system, it requires more number of bits to represent a decimal number than binary. It means here BCD code. So BCD requires more number of bits to represent a decimal number than binary number system. Okay, so this is the disadvantage. And what is the advantage you have by using BCD code, and why it is so much famous is it has easy conversion. It has easy conversion between itself and decimal. Okay, easy conversion between itself and decimal. Suppose if you want 538 to represent in binary, so we have to do all these things. So 538 has to be divided, successively divided, and later you have to take remainders in reverse direction. But if you want to represent in BCD code, we are doing it very simply, right? Just by writing each and every corresponding values. So 5 is represented 0101, 3 is represented by 0011, and 8 is represented by 1000. So there will be easy conversion between decimal and BCD, of course, from BCD to decimal also. Suppose if you have to group 4 bits, so these 4 bits represent 8 here, these 4 bits represent 3, and these 4 bits represent 5. So 538 base 10 is the corresponding decimal. So if you have a decimal code, you can easily convert into BCD code, and if you have BCD code, you can easily convert into decimal code. So that is the advantage here. So I have written here. So it has easy conversion between BCD itself, means BCD, between BCD and decimal. So easily you can convert decimal to BCD or from BCD to decimal. Okay, so this is how the BCD code works. Okay.